Part 2 of 4 on acid and bases. Now we're covering 10.2 bases and alkalis. In this section, you should be able to define alkalis as substances that produce hydroxide ions in aqueous solution, and describe what is meant by neutralization and write the ionic equation for the neutralization reaction, which is very important, and describe the properties of alkalis and their reaction with acids and ammonium salts. So what is a base? This is a very important definition. A base is any metal oxide or metal hydroxide that reacts with an acid to produce a salt and water only. So this is the general equation. Acid plus base give you salt and water, and this is called neutralization. So some example of bases are, for example, metal oxides, sodium oxide, zinc oxide, calcium oxide. All these are metal oxides, and these are metal hydroxides. So all metal oxides and metal hydroxides are classified as a base. So what's an alkali? Alkali is a soluble base which dissolves in water to produce hydroxide ions, OH-. And all alkalis are bases, but not all bases are alkalis. What does it mean? These are all bases. As you can see, all these are metal oxides or metal hydroxides. And these are the soluble ones are called alkalis. So alkalis are soluble bases, but since not all bases are soluble, so we can say that every alkali must be a base, but some bases are not alkali because some bases are not soluble. What's alkali? For example, sodium hydroxide is an alkali because it's a metal hydroxide. When dissolved in water, it produces hydroxide ion. Likewise for calcium hydroxide and even ammonia gas dissolved in water. And they all produces the hydroxide ions when dissolved in water. So what is responsible for the alkali property? It's very obvious, right? It's the hydroxide ions. Alkalis, some property of alkalis. Alkalis feel soapy and have a bitter taste. It turns red litmus paper blue, and it reacts with acid to form a salt and water only. And this reaction is called neutralization reaction. So please remember, acid plus alkali give you salt and water. Okay, let's try quiz 5. Please pause for a while, stop the video for a while, and try this question before you proceed. Okay, what's a base? A base is a metal oxide or hydroxide. What's an alkali? An alkali is a soluble base. Now give 3 properties of alkalis. Alkalis feel soapy and have a bitter taste. Alkalis turn red litmus paper blue, and they react with acid to form salt and water only. These are the 3 properties of alkali. And of course, alkalis being soluble in water, it can also conduct electricity because it has a mobile ions. Now what ion must be present in an alkaline solution? Alkaline solution, hydroxide ions. So next, we learn about the properties and reactions of alkalis or bases with acid and with ammonium salt. So acid plus base gives salt and water. For example, sulfuric acid plus copper 2 oxide. This is acid, this is a base. It produces salt and water. Let's recall, what is a salt? A salt is when an acid's hydrogen, for example sulfuric acid, the hydrogen is being replaced by a metal ion, which is copper replacing the hydrogen to form copper 2 sulfate. So when hydrogen ion is being replaced by a metal ion, this is a salt that's formed. For example, HCl is acid. When hydrogen ion is replaced by sodium, form sodium chloride, this is a salt. So acid plus a alkaline form a salt and water. So students need to know how to write chemical equations based on the general equation given. For example, sodium hydroxide react with nitric acid will give you what? Because alkaline and acid forms the salt and water, so sodium hydroxide and nitric acid will form sodium nitrate and water. So you must be able to transform all the names into a chemical formulas and write a balanced equation. Potassium hydroxide and sulfuric acid Obviously, potassium will take out the place of the hydrogen and they form potassium sulfate and water. So reaction of acid alkalis is neutralization. The only equation for neutralization is H plus equals plus OH minus equals give you H2O liquid. And this is a very important equation you need to remember. Okay, very important. Please remember this equation. This is called the ionic equation because it shows you the ions that takes part in the reaction. So which of these are neutralization reaction? Remember, by definition, neutralization reaction is one whereby an acid and an alkali reacts to form a salt and water only. So if you look at the first equation, salt and water, yes. Second equation, salt, water, carbon dioxide. When there's carbon dioxide, is it considered as a neutralization? No, right? How about this? Yes, salt and water. Salt, water, and chlorine. So you realize that when there's carbon dioxide on top of salt and water or chlorine gas on top of salt and water, it is not neutralization reaction. Next reaction, alkali. Alkalis when warmed with ammonium salts produce ammonia gas. And this another general equation is very important. Alkali plus ammonium salts or even base, for example calcium oxide, calcium hydroxide, a base plus ammonium salt. When you warm it, you form a salt water and ammonia gas. Please remember that. How to test for ammonia gas? When the gas is evolved in this test tube, you put a moist red litmus paper at the mouth of the test tube. If there's ammonia gas coming out from the test tube, you'll turn moist red litmus paper blue. In your syllabus, the only gas that is alkaline is ammonia. So when you turn red litmus paper blue, it's an alkaline gas and it must be ammonia. This is only one you study in syllabus. Another example of alkaline and ammonium salt. Sodium hydroxide is an alkaline because it's a soluble base, metal hydroxide. React ammonium salt to form a salt, water, and ammonia gas. How to form this salt? The metal plus the chloride form a salt. So salt, water, and ammonia gas. Potassium hydroxide, ammonium sulfate form potassium sulfate. And salt, water, and ammonia gas again. So some uses of bases and alkalis you need to know. For example, magnesium oxide is used in gastric pills to relieve gastric pain and also for refractory bricks. Now, as a gastric pill, magnesium oxide is reacting as a base because it neutralizes acid in the stomach. However, when used as a refractory bricks or refractory material, it is not behaving as a base, not reacting as a base. Okay, it's another property we'll go through in the next slide. Sodium hydroxide and potassium hydroxide is used in the preparation of soap. To make soap, you use sodium hydroxide and potassium hydroxide. You need not know the details at the moment. So what is refractory material? This is for information only. You can see that this is actually the entrance of a kiln, okay, of a furnace. And these refractory bricks line the inner surface of the hot furnace. You see this refractory material is to prevent the furnace from melting down. So a refractory material is one that retains its strength at high temperature. It does not melt, it does not deform. So this is another property of magnesium oxide. It has a very high melting and boiling point. So it can be used to make refractory bricks. Okay, next. Uses of bases. This is very important, take note of this. Now, when the soil is polluted by acid rain, okay, any contamination due to acidity, you use calcium hydroxide added to the soil to neutralize the acid in the soil. And this is also called liming the soil. And ammonia solution is used to make fertilizer, ammonium fertilizers for the plants. Okay, let's try this quiz. Please pause for a while and try. Acids can react with bases, carbonate, and metals. Which reaction does occur? Which of them produce a gas? Now, to produce a gas, it can be carbonates because it produces carbon dioxide, and acid reacts with metal produce hydrogen, but acid react with base only produce salt and water only. So you should look under base, there's no reaction, carbonate there's reaction, metals reaction. So answer is C. So please remember, acid plus metal produce hydrogen gas, acid plus carbonate produce carbon dioxide, but acid plus base produce a salt and water only. This is the definition of neutralization. Okay, let's try this question here. Please pause for a while and try this question. Why is magnesium oxide found in gastric pills? Because it is a base. Magnesium oxide is a metal oxide, it is a base, and it can neutralize the excess acid in the stomach that causes gastric problem. When there's excess acid in the stomach, when you have an empty stomach, and yet there's a lot of acid in the stomach, the acid will actually burn the stomach wall and cause gastric pain. So if you take the gastric pill containing magnesium oxide or hydroxide, they are bases that can neutralize acid and therefore relieve the acidity in the stomach, and then it reduces the gastric problem. What gas is formed when the base react with ammonium chloride? Ammonium chloride is an ammonium salt. A base and ammonium will form ammonia gas. Please note the spelling. Ammonium salt, ammonia gas. Describe a test for the gas in part 2, of course ammonia gas, and give the observation. Place a piece of moist, remember it must be moist. Without the moisture, the red litmus paper may not be able to turn color in the presence of ammonia gas unless the gas is moist. But in this case, we moist the litmus paper so that the gas can dissolve into the moisture and react with the litmus paper. So moist red litmus paper at the mouth or test tube, if ammonia gas is present, it will turn moist red litmus paper blue. Take note, the only alkaline gas I need to remember is ammonia gas turning red litmus paper blue. What is added to the soil to neutralize acidic soil? Calcium hydroxide. And this is very important. Students, please remember that calcium hydroxide is added to acidic soil to neutralize that acidity. Okay, that's end of part 2 of 4.